Hi students, in the last video we have seen pre-March 2025 ACCA performance management paper section A questions and answers I have explained. In this video let's see section B. That means the next 30 marks we are going to see in this. Section B starts from question number 16. As you know, there will be one short scenario. On that there will be 5 questions. Let's see what the scenario is about. Okay. The following scenario relates to questions 16 to 20. Fruity Company manufactures 2 types of concentrated fruit juices, Key and Max, for domestic and overseas markets. Both are made purely from fresh apples that are bought from a family-owned apple farm operator. The production of Key and Max shared the same production facilities where the machines in use are semi-manually operated. The standard cost and selling price information of both the products are given below. Key and Max, apple, machine, labor, other variable overheads. Total variable overheads 54.68. Selling price 58 and 74. Fixed cost $7,000. To ensure a smooth and uninterrupted operation, Fruity Company will always need to monitor closely on all the possible constraints in every upcoming month in determining the optimum production plan in order to maximize its return with the given constraints. Okay, constraints seems like, see if you see this, you know it is a linear programming related question. Let's see. In the midst of the planning process for the following month, Fruity Company has agreed to supply at least 2,500 liters of Key to one of the overseas customer, and the agreement has signed recently. So at least 2,500 of this product they need. Given the routine machine maintenance and normal staffing arrangement, the maximum available machine hours and labor hours for the following month are expected to cap 25,000 hours. Expected to cap means maximum. The cap means the maximum limit, 15,000 hours respectively. The apple farm operator has informed Fruity Company that the supply of apple will be kept at a quota of 24,000 kilograms. So there are 3 resource limitations you have. Based on the above constraints, it had formulated and graphed within the unknown K being output of Key and unknown M being output of Max. Okay, C1 apple 2K plus 1M less than or equal to 24,000. So seems like Key takes 2 kilograms of apple. Yeah, can see that here. See, $10 per kilogram. $20 means must be 2 kilograms. The other one only 1 kilogram. So they have done all those. We don't have to analyze. 2K plus M less than 24,000. Machine K plus 2.5 M less than or equal to 25,000. All the inequalities they have written. Since minimum order is there, K must be greater than 2500s. M has to be greater than 0. K, since you already wrote greater than 2500, even if you don't write it here, it's okay. Because if it is greater than 2500, anyway it can't be negative. But they have written K and M greater than 0. And they have drawn the graphs as well. C1 is for constraint 1. C2 is for constraint 2. C3 is the constraint 3. So you can see that this part, where starting from here, C, D. Not starting from here, because A, you have to start from here. 2,500 minimum is required. So look at this. A, B, C, D. A, B, C, D, A. That will be the feasible region. Here this one A, B, C, D, A. Within that answer has to be there. And they have drawn the contribution line also. Can you see this one? ISO line is also drawn here. 4K plus 6M. How did they get 4K plus 6M? 58, 54, $4. Here $6. So 4K plus 6M. Contribution line is also drawn. Coming to the requirements. Which of the points represents the optimum production plan? Optimum production plan. So what we have to do, this line, I have to keep moving, keep shifting outwards until it completely goes out of the feasible region. So you can see here, let me see. Just for you to understand, I'll draw a line, another line. No. How do we get straight lines? Okay, let's see. This can be another one. Can't I get straight lines? Let me try. Okay, this is one parallel line, can I say? But why is it thick and thin? Let's draw it manually. Okay, this is one line, this is another line. That's not parallel. See what we can do then. This line, I have to keep moving outwards, outwards, outwards. Can you see it passes D, it passes B, it can still further move on, it can move on, it can move on. Now we are almost about to exit the feasible region, isn't it? See, now we are passing the feasible region. Once again, see, let me mark the feasible region for you. Feasible region starts from here. This is our feasible region. Can you see what I am marking with the yellow color is our feasible region. Our solution has to be within this region. Right, that is what they mark. Okay, it can come up to here. Yes. Okay. A, B, C, D, A. In this is the feasible region. Then what do? I draw the objective line. Objective line is already here. So I draw a line. In the exam, you can't draw a line like this. So what you do, maybe you can keep a pencil on top of this, or a scale ruler you can top of the ISO line, and keep shifting it outwards. Keep moving it. Move, 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 move. Slowly it goes out of the feasible region. That's okay. Still there is some part within the feasible region. It's okay. Move on, move on, move on. See, the last point that we pass is point C. Point C. So that point C is going to be the optimum solution. Next. How do I erase all of this? Okay. Now what do they ask? Calculate the maximum profit earned for next month. So if you want to find the maximum profit, I need to find the coordinates of C. So if it has fallen on a point like this where two lines are intersecting, I can just read it from the graph. But here it is in the middle of a cell. So I can't just read it from the graph. Then what we will do, we will solve the equations. Which ones we are going to solve? Look at this. C1 goes through that point, and the other equation is C2. Those are the two lines that intersect at point C. Once again, see, C1 and C2. C3 doesn't go through that. So take the C1, C2 equations and we have to solve it manually. That is only option. So C1 is 2K plus M, 24,000. Let's solve it. Okay. So C1, what's the formula? 2K plus M, 24,000. 2K plus M, 24,000. C2, K plus 2.5 M, 25,000. So what we will do, this, keep it as it is. This one I am going to multiply by 2. Why? Then I can get 2K. So if I multiply this by 2, second one multiplied by 2, 2K, 5M, 50,000. Let me call it third one. Now from the third one, subtract the first one. 2K, 2K nullifies. 5M, 1M, 4M. 50,000, 24,000, 26,000. Solve that. M is going to be, if you divide by 4, you get 6,500. Then go back to the first one. Substitute this. 2K plus 6,500 is 24,000. So 2K will be, if you subtract on the other side, 17,500. K will be, if you divide by 2, 8,750. You got M and K. Already we saw the contribution formula. 4K plus 6M. 4K plus 6M. 4K plus 6M is the contribution. 4 into 8,750 plus 6 into 6,500. How much is that? $4K plus 6M. 4 into 8,750 plus 6 into 6,500. 74,000. That is the contribution. From this contribution, you have to subtract the fixed cost. How much is the fixed cost? I remember it was 7,000. So from this, you subtract fixed cost of 7,000. 67,000. 67,000. Let's mark the answer 67,000. Next one. Based on the optimum production plan, which two of the following represent binding constraints? Very easy. Go to the graph. You know this C is the optimum point. Whichever the lines that go through that optimum point are binding constraints. So C1 goes through the optimum point. C2 also goes through that. So those two are the optimum constraints. C3 doesn't go through that. Minimum order doesn't go through that. They are away from the optimum point. So it's only C1 and C2 binding constraints. Based on the optimum production plan, which of the following statements about shadow price is true? Only the binding constraints will have shadow price. So there will be a shadow price for all three? No. There might be a shadow price for minimum order? No. There will be a shadow price for machine and labor? C1, C2, right? What is C1? Apple and machine. Last one. There will be shadow price for apple and machine. Correct answer. Apple and machine. Which of the following best describes the feasible region of ABCD above? It shows all possible, it shows all feasible production plans that meets all the constraints. Of course, yes, that part is right. With the possibilities of more than one optimum production plan. Can there be more than one optimum solution? In this question, no. Let me explain to you. Look at this. Okay, you had one line like this, then another line like this, another line like this. Right, this was your optimum feasible region. Which one? This was your feasible region. Done. Now we will see our constraint formula, or the objective function formula. It was something like this. See this line, if I keep moving it, when I move it, it just finally passes through one line only, one point only. Can you see? The last point is just a point, one point. So this scenario, we have only one optimum solution. This was the scenario in the question we did. Therefore, answer to the question is, it shows all feasible production plans that meets all the constraints with only one production plan, one optimum production plan. Okay. Then the question arises, when will we have more than one optimum production plan? Look at this. Suppose if the suppose if the objective line was something like this. Look at this, not that. We'll take blue. Okay. Let me keep this away here. Okay. Suppose if the objective line, I was trying to copy this line, didn't work anyway. Objective line, if it was parallel to one of these lines, imagine if it was parallel to one of these lines, if it is something like this, then when you are moving it out, see it moves. When it is exiting, can you see it doesn't exit from one point, it exits from whole line. If it was a straight line, that's how it would have been, isn't it? See? If it exits from one whole line, not from one point, when does this happen? If the objective line is parallel to one of the constrained lines. In that case, we will say multiple. That means all the points in between these two, all the points in this range would have been optimum points. So that is what we call multiple optimum points. Multiple optimum points. So once again, see, when do we have one optimum solution? If the objective solution is not parallel to constraints. When it is multiple optimum points, if the objective line, the ISO line, if it becomes parallel to one of the constraints, then there will be multiple solutions. So answer to this question, here we had only one solution. Right, that's all about that linear programming solution. Now we are coming to the second set. It's about market share variance and market size variance. Let me quickly recap that before we go to the calculations. You know, sales volume variance, the formula is this, actual volume. If you are using the formula, there are different methods of finding it. I usually encourage the formula method. Actual volume, budgeted volume, standard contribution per unit or profit per unit, depending on the accounting method used by the company. If the company uses marginal costing, it will be contribution. If the company uses absorption costing, it will be profit. Okay. Now, this can be split into two. Sales volume or let's say market size variance, market share variance. When does this happen? Sometimes the market size, overall market size changes. Maybe government encouraged that product, so it became more popular in the market, or government gave some subsidy because of that it became popular, or maybe one of the technology advancement has been adverse to this company, so this product became not that favorable, not that famous, so the total market size dropped. Something like that can happen. When that happens, what do we do? Actual volume, budgeted volume, in between include another one called revised budgeted volume. You will have to revise the budget. How do we apply? See, I'll show you in this question. In this question, if I go, anyway, let me finish explaining. Right. So here market size variance is going to be revised budgeted volume minus budgeted volume. Both budgets you compare. Why did we revise? Because market size changed. Because of the market size change, overall market size changes, we revised this into standard contribution per unit in marginal costing. Here, actual volume, revised budgeted volume into standard contribution per unit. Take 2 by 2. These two together, that will be the market share variance. These two together, this will be the market size variance. How do we get the budgeted volume? Original market size, I'll write it here. Budgeted volume is original market size multiplied by planned market share. what percentage of market you are planning to have. Then revised budgeted volume will be revised market size multiplied by same planned market share. Market share means a percentage they will give you. I'll explain with this question. See, in this case, we can even call this as planning variance. Market size variance can be called as planning variance. Market share variance can be called as operational variance as well. Because this is what is controllable by the managers. This is the performance of the managers. This is basically outside factors. Right. So this is the background knowledge. Now let's go to the question. GT Technology Company is one of the established smartphone manufacturers in Giland. The board have been concerning about the future outlook for the company given a rapid changing industry landscape with increasing number of smartphone manufacturers from both local and abroad market players. With the recent rapid economic recovery in the region after a long downturn due to a global pandemic, the sales and marketing team has been adopting an aggressive strategy such as aggressive promotion campaign and setting competitive pricing strategy attempting to broaden their market presence in Giland. The board is reviewing the sales performance of the company in the past 1 year based on the following information. Original market size is this. Can you see actual market size is bigger? Because of this, I may have to revise my target. Budgetary target has to be revised. Market share planned is 16%. But actually what we achieved is 10%. Okay, then cost details are given. Question is market share variance. Right. So before that, let me say original budgeted volume. See, this is the original budgeted volume, 15 or 1.5 million into 16%. 1.5 million into 16%. That is 240,000 is the company's budgeted volume. Revised budgeted volume. Why are they revising it? Because of this. What? Actual volume or actual market size is different. Now actual market size is 2 million. So when the actual market size is 2 million, if you kept your relative competitiveness same, that means if you achieve the same 16%, you are supposed to get 320,000 sales. This I will call it revised budgeted volume. Then actual volume, what they actually achieved on this 2 million, they achieved only 10%. See, both actual market size, actual market share. This is the revised market size or actual market size into budgeted market share. That's the revised budgeted volume, 200,000. So market, which one they ask? Share variance, market share variance. What did I say? Actual volume, revised budgeted volume into standard contribution per unit. Formulae, if you practice, it's fast, guys. It's fast. You can get the MCQs, section B questions much faster. Actual volume 200,000, revised budgeted volume 320, standard contribution per unit. Look, 340 is the variable cost, 650. Get the difference? 340, 650, 310. Multiply by 310. How much do you get? I need to type 200 within brackets 200,000 minus 320,000 multiply 310 minus 37.2 million. Do we have the answer? Adverse 37.2 million. There you go. Adverse 37.2 million. Next. What is the market size variance? Okay, that's easy. Market size variance. What's the formula? Original budgeted volume, revised budgeted volume. No, other way. Revised budgeted volume into standard contribution per unit. How do you remember what order? That's why I gave you this formula. Look at this. Original, like basic variance formula is actual volume minus revised budgeted, actual volume minus budgeted volume. Basic variance formula. Now in between you include revised budgeted volume. So take these two in the same order, that is one variance. Take these two in the same order, actual volume, revised budget volume, that is another variance. So you will remember easily in what order to take. Okay, so revised budgeted volume 320,000, budgeted volume 240, contribution 310. So this is 80,000, 2480. Let's check with the calculator to be on the safe side. 320,000 minus 240,000 multiplied by 310. 24.8 million. 24.8 million positive. 24.8 million favorable. Okay. Next one. What is the sales price variance? Sales price variance, the basic variance formula, basic variance, easy. Price variance, how are you going to find it? Actual price, standard price, actual volume sold. Actual price 600, standard price 650. 600, 650. What is actual volume? I have written somewhere. Actual volume. Here, 200,000. Actual volume is 200,000. So that's going to be 2 million, 10 million, is it? Minus 10 million. Minus 10 million. Do we have the answer? 10 million adverse. Minus 10 million. Easy. Which of the following commentary best describes the sales performance of the company in the past year? The aggressive strategy adopted by the sales and marketing team has proven to be effective. No. Why I say no? Aggressive, like the performance is shown by market share variance. This is their performance. Market share variance, how much is it? Adverse. Can you see significantly adverse? So their performance is bad. Whatever the strategy they have taken, whatever the action they have taken, it did not work really well. So that statement is wrong. The aggressive strategy adopted by the sales and marketing team seems not as effective as it planned. That must be the answer. Look at this, guys. When you give two statements like this, one opposite to the other, definitely one of them have to be the answer, right? If this is the answer, that is not the answer. If first one is the answer, second is not the answer. You don't even have to see the other statements. They say, first one they say it worked. Second one they say it did not work. So either of that has to be the answer, right? Use your common sense. So in this case, it did not work. Anyway, let me check the other answers to explain you. Sales volume performance was mainly attributable to factors beyond the control of the sales and marketing team. Sales volume variance is mainly attributable. Let's go and see. Look. No. Main variance was like big variance was market share. Market size is smaller. So which is main? Market share variance. Which is controllable? Which is the performance of the team? They say it is not controllable. That is wrong. Beyond the control? No. Suppose if I got the answer like market size variance is very big, market share variance is small, then their answer is right. Because market size variance is beyond the control. Sales volume performance has outperformed as compared to the budget. Sales volume at these two and see. No, still minus. Can you see? This is minus 37.2. Minus. This is plus 24.8. So minus is bigger. Answer is going to be minus. So overall volume variance is going to be adverse. Overall volume is adverse means outperformed is wrong. Underperformed. Which two of the following variances are most likely to reflect responsibility area? Definitely market share is controllable. Market size, no. Sales volume has both of them. So I cannot say it is fully controllable. Price variance, yes. Unless otherwise there was a planning change. Usually in this case there was no change in the plan, no change in the price. Therefore, price variance is controllable, operational. Next set seems like ABC, cost pool, cost driver, nice. Solar company produces a range of solar based household lighting systems such as ceiling light, garden light, table lamp, and others. With the advanced manufacturing technology in use, some of the simpler products were produced from a few sharing production lines, while other products with more sophisticated electrical components were produced from another set of production lines. For product valuation and pricing purpose, company adopt a cost plus pricing approach with 20% markup on production cost. As for the system of production overhead absorption, a traditional single factor model based on machine hours have been used. However, as a preparation to apply ABC system for overheads absorption, the budgeted information of the company for the coming quarter that fit ABC system are as follows. Right, 4 types of costs are given, cost drivers are given. Okay, the above budget has included estimated activities required for a quotation required by a small construction company to supply 2 models of garden lights, model X and model Y, in the coming quarter. Okay, estimated activity levels for the quotation are given below. This is for one particular order, right? Based on the existing overhead absorption system in use, the proposed price to be quoted are 80.4 and 68.4. Based on existing system, which option shows overhead absorption per unit of model X and model Y? Okay, let's see. Let's get some more pages for us to work. There you go. First, let's find the OAR. Total overhead was given 1.48 million divided by machine hours. Here you have the total machine hours. Don't be deceived by taking these 2 machine hours. That is for one particular order. I need all the orders together, which is 200,000 total machine hours. This is the total overhead. So 1.48 million divided by 200,000, which is 7.4 OAR per machine hour. Then first product X, Y. X takes how many hours? Machine hours 35,000. That's for 5,000 units. Can you see? 5,000 units. So if you divide it, it's going to be 7 hours. 35,000 divided by 5,000. 7 hours. X takes 7 hours each. So 7.4 into 7. 51.8 per unit. Y rate is same. How many hours does it take? 20,000 hours for 4,000 units. If you divide it, that's 5 hours. 5 hours. Multiply by 5. $37 per unit. Do we have the answer? Okay, there you go. Option 4 is right. Next. Based on ABC system, which option shows the overhead absorption rate? We had to apply ABC. That's going to take time. However, look at this. If I do it for one product, that's enough, because there is no same answer repeating. 40.5, 37.25, 19.25, 13.75. If I get one of these right, then I don't have to check model Y. I can, if I'm confident about my working, I can say that's going to be the answer. So let me do it for X, and I'm going to finish the working. Look at this. Right, let's keep it here. Okay. Right. First one, 320,000. That's for 40 setups. So this will give you answer for one setup. How many setups for X? 4 setups. Finally, let's calculate. Next one, component handling, 300,000 total. That's for 100,000 parts. How many parts for this X? 6,000 parts. Third one, 550 production overheads divided by 200,000 machine hours. So that gives per machine hour, X takes 35,000 machine hours. Last one, 400 divided by 50 that gives the rate 400 multiplied by 5,000, isn't it? 5,000. Get the answer. This I can solve without the calculator. 4, 10 is going to be 32,000. This also I can try. 3 into 6,000, 18,000. You can use the calculator, no problem. This will be better if I use the calculator. 550,000 divided by 200,000 multiplied by 35,000. 96,250. 96,250. Here it's 40,000. Let's add all of them. 32 and 18, 50, 90, 186,250. This is total. Question was per unit. This is for how many units? This is for 5,000 units. So divide it. 186,250 divided by 5,000. 186,250 divided by 5,000. 37.25. For X we are getting 37.25. See, one by one there are 4 activities and drivers. So divide by the cost pool divided by cost driver. Within the bracket you get the rate. Multiply by first product's usage. It uses 4 setups. So multiply by 4. Next one, 300 divided by 100. 6,000 is the usage. So do that for all 4 activities. Add them together. Finally divide by number of units. 37.25, option 2. I am not doing for model Y. Right? Straight away I can say it's option 2. Anyway, since we are doing it for practice now, I'll do it for Y also and check whether we are right. So if you are doing it for Y, okay, look at this, 320,000 divided by 40 into 6 it will be. So that's going to be 48,000. Next one, 300,000 divided by 100,000 into 9,000. So that's going to be 27,000. Next one, 550 is the cost pool divided by 200,000 is the driver, 20,000. That will be 55,000. Next one, 400,000. This I am doing for Y, product Y. Not needed to answer the question because with one answer itself, with X itself, we can finish the answer. We can finalize the answer. However, for practice, I am doing this. So it's going to be 400 divided by 50 is 8 into 4,000, 32,000. Add them together, 48 plus 32 is 80, 107, 162,000. That's for how many units? 4,000 units. So divide it, 162,000 divided by 4,000. 40.50 we get. Check the answer. Is that what we had? 40.50. See, option B, option 2 we selected is correct. Next. Select whether each of the following statements pertaining to the price quoted for model X and Y are correct. The price quoted for both model X and Y are likely to affect the markup achieved as compared to the target of 20%. Definitely, because the costs have changed. You want to have a look at the costs. See, under ABC what we got now, I can check the answers I marked. Under ABC we got 37.25 and 40.5. This is overhead only. The prime cost wouldn't change. 37.25 and 40.5. In the absorption costing, what did you get? Previous answer. We got option 4, 51.8 and 37. 51.8 and 37. Can you see the cost, the overheads have changed compared to absorption costing? ABC cost is lower for first product. For second product, compared to absorption costing, ABC is higher, which means your margins will change now. If you still stick to the same price, what was the price? 80.4 and 68.4. So whatever the margin you used earlier, I can't directly find the margin because I need to add prime cost with this, direct cost with this, and then only I can find what is the margin or markup. Whatever, since the cost has changed, margin will change. So that answer is right. Which one we are doing now? 27, 28. So this is correct. Price quoted for model X are likely to be underpriced. Y are likely to be overpriced. Let's see. Look. Now this 80.4 is based on the original cost. Right? Now when the cost is lower, when the ABC cost is lower, price has to be lower, right? But you are keeping it at 80.4 means this is an overpriced product. Basically, you have overstated your cost. Because you have overstated the cost, price is also overstated. In the other case, the original cost was understated, where the correct cost is 40.5, but you have shown it as 37. Cost is understated, so the price is also understated. So X is overpriced, Y is underpriced. I think here they are telling other way around. They say X is underpriced. No, that is wrong. X is overpriced, Y is underpriced. The prime cost per unit of model X and Y are 15.2 and 20 respectively. Based on the price quoted, what is the revised markup? Okay, markup. Right, I already have these values. What is it? Price is 80.4 and 68.4. Cost will be, I need to add 37.25 and prime cost how much? 15.2. I can do for only one and finish it. Anyway, for practice I am doing another one also. 40.5 plus 20. So this is 40, 52.45. So the profit is going to be if you subtract 80.4 minus 52.45, 27.95. This minus this, subtract it. So profit markup is what they ask. Profit markup means profit divided by cost. So this is the cost. This is the price. Right. So it's going to be 27.95 divided by cost is 52.45. You get 53.3% or 53.29%. Check whether you have an answer with 53.29%. There you go. Option 1 is there. Just to double check, if I have time, I can do for model Y also. Model Y. This is 60.5. So when you subtract it, it's going to be 7.9. So markup has to be profit divided by price, profit divided by cost, 60.5, 13.06%. Yes, that is right. So option 1 is right. Last one. Which of the following statement is not true about the adoption of ABC? ABC system will not improve the accuracy of product cost information regardless of the complexity of the production process. No. If it is a highly complex process, if you have more machinery, more automated systems, ABC will improve the costing. If it is a very simple process, not much of complexity, ABC may not improve much. Here they say it will not improve at all. That is wrong. So that is the answer, which is not true. Anyway, we'll check the other statements. ABC system is more suitable for a highly automated manufacturing environment. Yes. ABC system may require significant change in the design of the information system. Yes, because the way you are going to collect information, activity-wise, we have to collect the cost pools. So yes, you need a different system. ABC system may lead to improvement in both profitability and market competitiveness. Yes, when your pricing is improved, you will become more competitive in the market. And when the pricing is correct, when the costing is correct, your profitability also will be improved based on that. So these three statements are right. The first one is wrong. Clear? This is all the section B questions from pre-March 2025 mock exam for ACCA performance management. In the next video, I'll show you the answers for questions and answers for section C questions, both 20-mark questions. We'll see in the next one. Thank you.